Hi everybody. So in this video I'd like to talk to you about voltage divider circuits. But before we get into voltage divider circuits, let's review our basic circuit because I want to introduce a new way of thinking about voltage that's going to help us as we look at this new voltage divider circuit. So our basic circuit, of course, consists of a battery connected across a resistor. Got the positive terminal, negative terminal, and the voltage acts like a pressure pushing current through the circuit where it's limited by the resistor. Now the charges come out of the positive end of the battery, go through and then recombine in the negative side, and thinking about it in terms of a pressure or electrical attraction, that all works just fine. But another analogy is to think about it in terms of height and in terms of pumps and water and things like that. So in this analogy, if you think about the current as a flow of water and the wires acting like pipes, then the battery acts like a pump. And the negative side of the battery, that acts like ground level. So imagine you've got water at ground level, and as you go through the battery, that pumps the water up a hill, up to a height. So the positive side is like the top of a water tower or something like that. So we start at ground level, we pump the water up to the water tower, and then going through the resistor is like that water flowing downhill through like a water wheel or something like that. So water, ground level, pumped up to the top of the water tower, and then it flows downhill through the resistor and back down to ground level. And so in this analogy, the water is making a complete loop around this way. So it goes up, then it goes down, then it goes back to where it starts, goes up, down, so on and so forth. And this is one of the reasons we call circuits is because they're dealing with complete paths or circuits of charges or charge movement. So this analogy is going to be helpful for us as we think about and try to understand voltage divider circuits. Now, a voltage divider circuit, what that's doing is that's going to, like the name suggests, reduce or divide a given voltage source down below its value. And this can be really handy in all sorts of different applications. And to start drawing that circuit, I'm going to also show you another point of notation. With this basic circuit, instead of having the negative at ground, at the negative terminal of the battery like this, I'm going to represent that as ground. And the symbol for that looks like this. So this is what we call ground. And we've been using the negative terminal of the battery for ground in all of our previous examples. So I can redraw this circuit here as a voltage. So this corresponds to the positive terminal of the battery going through a resistor back down to ground, where this is like the negative terminal. So these two circuits are equal to each other. This way is a nice, more compact way of drawing the circuits, even simpler than this way. Remember, this voltage here is like the positive terminal of our battery, and this ground is like the negative terminal of our battery. So let me clear out the board, and we'll draw a voltage divider circuit and see if we can use these new ideas and understand this circuit. So for our voltage divider circuit, we've got some input voltage that we want to reduce or divide. It's going to pass through two resistors on its way back to ground. So remember, Vn, that's like the positive terminal of our battery, and ground is like the negative terminal of our battery. Before I go any further, let's just see if we can understand this circuit using our new analogy of water pumps. So the water starts down at the ground level, and then it's pumped by the battery uphill to Vin. Then it flows through the resistors, goes downhill a little bit, and then goes downhill back to ground, where the battery then pumps it back up, goes through, down, 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 back up, and completes this circuit. Again, I've left off the battery picture here, but this Vn is, again, like the positive terminal, and the ground symbol is like the negative terminal. So the battery is here just implicitly here. And if we think about this, as we go from our voltage that we want to divide, we go through this first resistor, our voltage drops as we flow through this resistor, and then it drops again all the way down to ground. So this point here, we'll call V out. This is going to be in between Vn and ground. Ground is also sometimes referred to as 0 volts. So that means that 0 is less than V out, and V out is less than Vn. So V out is going to be somewhere between Vn and ground. And so that gives us our voltage division. Now, if these resistors are equal to each other, that means we go from Vn, we go down. We'll go down a little bit here and then down the same amount through here. So V out should be halfway between Vn and V out. So let me, to quantify this, let's label these R1 and R2. So in the case that R1 equals R2, then V out equals 1/2 Vn. And again, that's because half of the voltage is dropped through R1 and the other half is dropped through R2. Now let's think about what happens if R1 is a lot bigger than R2. So if R1 is a lot bigger than R2, that means that we're going through a much bigger drop through R1 than we are R2. We're going downhill a lot more through R1 than we are through R2, which means that we go from the top of the water tower, we go way down and then just a little bit further to get to ground. In that case, that means that V out is going to be close to 0 volts. If, however, R1 was much, much less than R2, what that means is we start at the top of the water tower, we go down just a little bit, and then we go down a lot to get back to ground. In that case, V out is going to be close to Vn. And again, if R1 and R2 are equal to each other, then V out will be half of Vn. So these are the basic ideas of a voltage divider. You can go through using Ohm's law and do the mathematics and figure out exactly what the voltages are. But these three cases are good enough for most of the things we're going to be doing in this series. So just to recap, if R1 is much bigger than R2, the output's very close to ground. If R1 is much less than R2, the output's very close to the input. And if these two guys are equal, then V out is halfway in between